So anybody can confirm my screen is visible? Hello, am I audible?
Yes, sir.
Okay, thank you. So good afternoon. So let's revise like what we have seen yesterday in the last lecture. Last lecture we have seen the TCP/IP model, right? So let's summarize. Like it has some 4 layers, right? It will start from the lowest one, then it goes to link layer, right? Uh, so So starting from bottom, host to network layer, then the next is the network layer or internet layer. And transport layer, and then application layer. So we have seen each layer one by one. So all layer have some dedicated protocol, right? So uh, those protocols should be satisfied when you want to do the successful transmission of data, right? So if we are sending the data, you are sender, your device or your node is sender, then uh, for you it will start from the application here, right? So once you will do you will transmit them some data, and starting from application layer, right? All the, or we can say the whatever the protocol is needed for your particular service or your particular task, right? Those will satisfied. After that it will come to the next layer, the bottom one or lower one, that is the transport layer. After that it will come to the network layer, and the last goes to network layer, right? And from there data will send through the physical link, right? And on the receiver side, right, it will start like from bottom. So that we have seen, right? Also we have if we compare, then like OSI model has 7 layer, here we have 4 layer, right? The bottom 2 layer of OSI model, that is physical layer and data link layer, right? That are, we can say, combined in this host to network layer. And the top 3 layer of the OSI model, those are the application, station, and presentation layer, right? Those 3 are combined in a single layer in TCP/IP model, right? And that is the application layer, right? So if we'll summarize, then the host to network layer, right? It's mainly concerned with the physical connection or physical transmission of data, right? Then next, the second, that is the network or internet layer, right? So it is generally deal with the protocol which are for logical transmission of data over the network, right? Then the transport layer, it's responsible for the error-free or end-to-end delivery of data, right? So it has the task of transport the data, right? And the last one, that is the application layer. So it is define the interface for the users, we can say, right? Or interface of the host program with the transport layer, which is the upper one, right? So that we have seen. Then we have seen the function for all the layers, right? Uh, so right. So that is the TCP/IP model. Now today we'll start the OSI model. So the OSI stand for the Open System Interconnection Model, right? Its full form. And this protocol is developed in some 1984. So in 90s it was developed, and that is developed by the ISO, International Standard Organization, right? So as I told, right, TCP/IP is the, we can say, uh, was developed before this OSI model, right? It was developed in some 1670, right? And this OSI is developed in 1980. This OSI model is a conceptual model, right, used for network communication. So, as I told, it's a hypothetical model, right? Means not entire model is implemented, right? But still, we are taking this model as a reference today, right? This model gives a layered networking framework, right? That conceptualize how the communication should be done between two heterogeneous systems, right? So it's again, it has the layered architecture. This model describes how information from a software application from one node will move to the another node in the some other application or some other software, right, through physical medium. So this OSI model divides this whole task of this data transmission, right, or communication into several modules, or generally it has 7 layers. So we can say in 7 smaller manageable tasks, right? So this model divides whole task into 7 small modules, right? And each layer has assigned a particular dedicated task, right? So all the tasks are independent. So similar to TCP/IP model, if you want to modify some uh, task or some functionality in a layer, you can do that, right? It will not affect the other layers. Each layer is self-contained, right? So each layer can be performed independently. Uh, this consists of 7 layers, right? And each layer is connected with the other layer, right? So all the 7 layers are connected with each other. And generally what happens, generally all the layer have to deal with the layer which are upper and lower, right? So if you are from sender side, then your layer has to deal with the, means it will take some information from the upper layer and it will then pass into the lower layer. And on the opposite side, at the receiver, particular layer will take the information from the lower layer and it will pass that information to the upper layer, right? So here you can see the data moves down in OSI model, right? And each layer adds some additional information, right? Whatever information they are received from the uh, previous layer, right? They will add some more information in that and then they will pass. And this will continue. These processes continue, right, till the information reach to the last layer, right? And when data is received at the last layer, right, then data is transmitted over the network through physical medium, right? Physical medium is through some cable. Uh, and once the data is reached on the other side, right, then the process will get reversed, right? So this is the OSI model. So here you can see all the layer, right? So from bottom you can see like layer 1 is physical layer, layer 2 is data link layer, layer 3 is network layer, layer 4 is transport layer, layer 5 is session layer, layer 6 is the presentation layer, and 7 is the application layer, right? And at the bottom you can see the physical link, right? So where we have the physical cable. So you can see here I have this arrow direction. You can see it is in the both direction, right? So in the left side you can see start from the bottom and it will go to the top side, and the right side it is from upper layer to the lowest layer, right? So that because of we are we have one computer is as data sender, and the second one is the receiver. Right? Now you can see here the all the 7 layer, right? They are group, right? They are divided into, we can say, 2 group, or we can say 3 group, right? So the one group which is of layer 1, 2 and 3, physical layer, data link layer and network layer, right? Those group is known as the network support layer. So these 3 layer have to deal with the networking part, and the top 3 layer, which are session layer, presentation layer and application layer, right? So they have to deal with the users. So we can say these are the users support layer, and this middle one, that is the transport layer, right? That middle layer will connect this upper group with the lower group. So the transport layer will connect the user support layers with the network support layer, right? So it is like a link between these two groups, right? Uh, so this network support layer, right, which are at the bottom, right? This layer manages the physical transfer of data from one device to the another, right? And this user support layer, right, this allows communication among unrelated software in a dissimilar environment. So they have to deal with the users, right? And user end means you have some application or you have some software, right? uh, right? So we can also say that uh, upper this 4 layer have a responsibility of the host. Host means users, right? And the lower 3 layer have the responsibility of the network, right? Uh, so right, also we can divide this OSI model into 2 types of layer, right? So upper layer and the lower layer, right? So this upper layer mainly deals with the application related issue, and they are implemented only in the software, or some, if you are using mobile, then mobile application, right? And the application layer, right, which is the closest, which is the last layer, right? You can see, right, here the application is the last layer. So this application is closest to the end user, right? Both the end user, which both means if one is the sender and one is the receiver, so both the end user and the application layer interact with the software application, and upper layers refers to just above the another layer, right? Upper layer refers to the layer just above the another layer. I think some mistake in this sentence. Okay, no problem. Then the second part, that is a lower layer, right? So these layers are deal with the data transfer issues, right? In that we have data link layer, physical layer, right? So these data link and physical layers are implemented in hardware and software both, right? These upper layers generally implemented in the software, whereas this lower layer, right, which are implemented in both hardware and software, or we can say they have to deal with both the hardware and software, right? And in this, the physical layer is the lowest layer, right? And it is closest to the physical medium, right? And the physical layer have main responsibility for placing the information on the physical medium. Means they have to place the information, the data, on the cable, we can say, right? Now, if you want to give the overview of the OSI model, or we can say we have to just summarize like what is the main responsibility or main task of each layer, right? Then we can say like physical layer, it's provide physical medium through which the data in the form of bits are transmitted, right? Then the second layer, it's data link layer, so it is used for error-free transfer of data frame, right? So when we will see all the layer in the detail, right? So at that time we'll see like in the physical layer, data is in the form of bits. The data link layer, the data is in the form of frame, right? Then the third layer is the network layer, and this layer is responsible for moving the packets from source to the destination, right? So here you can see this packet is also nothing but the data, right? So it's responsible for moving the packet from source to destination, right? Then the fourth is the transport layer. Transport layer, it provides the reliable message delivery from process to process, right? So whatever the process, for each process we can see it's provide this message delivery, right? Then the session layer, so the session layer is used to establish, manage and terminate the sessions, right? uh, then the presentation layer is for the translation, compression and uh, encryption, right? So for that task that will happen at the presentation layer, right? And the top is the application layer, right? So this layer provides the service to user, right? So whatever the view you can see, right, in the software on the mobile application, that is, you can say, the application layer, right? uh, so we have seen this overview, right? Right? So in application layer is provide high level API, right? API means application program interface. Okay. Also in application we have GUI, right? Graphical user interface. Right? So that is also part of, you can say, application layer. Okay, so let's see all layers one by one. So the first layer, that is a physical layer, right? And this will deal with the transmission of individual bits from one node to the another node over the physical medium, right? So if you see the figure, I have highlighted the physical layer with the pink color, right? So they have connected and they are connected through a physical link, right? So one is from sender side and one is from receiver side, right? uh, so the physical layer is lowest layer of Osi model, right? It's establish, maintain and deactivate the physical connection, right? So it will establish, it make the connection, right? It will maintain the connection uh, during the data transmission, right? So if you're depends on the size of your data, right? You have to maintain that connection, right? If the data is of small amount, right, then maybe you have to maintain the connection for some minutes. If you have a large amount of data, then you have to maintain that connection for more time, right? In some several minutes. So this layer, it make the connection, it will maintain the connection, and once data is transmitted successfully, then it will deactivate it or disconnect the physical connection, right? This layer, it specify the mechanical, electrical and procedural network interface specification, right? So it will specify all the specification related to the physical connection, right? Uh, so if you see here in the figure you can see, uh, if it is from sender side, then left hand side you can say it will take the information from the data link layer, right? So there you can write, you can see this L2 data, right? And at the physical layer it will convert it into form of the bit, right? And those bits are transmitted through the physical medium, and right side you can see the receiver, where you can see the bits are received at physical layer, and after some processing at physical layer, right, the physical layer will add some additional information, and it will pass that data to the upper layer, that is the data link layer, right? So here you can see in the left side data is coming from data link layer, and the right side you can see this data is going from physical to data link layer, right? So as I told, right, the each layer will deal with the upper and lower layer, right? So let's see the main functionality or function of the physical layer. So the first function is line configuration, right? So this physical layer defines the physical characteristic and the function of physical device and interface so that the transmission can occur, right? This layer will define or will tell about the number of pins in each of the device as well as the purpose of each pin. So you can see, like, whenever you connect the two PC, for example, to the Ethernet cable, in Ethernet cable also you have uh, more than one wire, right? Some 6 to 8 wire you have, right? So that is like in your connector in your PC, in your CPU. If you see the connector, right, it has some number of pins, right? Not single pin, it has more than one pin, right? So this physical layer will state those number of how many number of pins and the purpose of each pin. Then the signal, so uh, this layer, it's lay out the transmission medium and type of the signal for transmitting the bit, right? So it will define the types of the signal, like it's electrical signal, it's optical signal, and in the case of the wireless technology, right, it may be a radio signal, right? So that is defined by physical layer. It's defined the procedure of the encoding of the bit. For example, how many volts should be represented 0 volt and how many volts will represent the bit 1, right? In the case of the electrical signal, right? In optical signal, it has also a different representation. On for radio frequency signal, it has some different representation, right? So that encoding and decoding that process, it's defined by this physical layer, right? Then this layer also defines the topology, right? When you connected your laptop in a network, so that network is in which type of topology, right? It's star, it's a mesh, or it's a ring, right? So this topology means physical layout of the network device, like how the devices are connected with each other, right? Then also it states the direction of transmission, right? So direction means yesterday I told, like, your communication or transmission is of which type: simplex mode, half duplex mode, or full duplex, right? So if simplex, then one way communication is possible or one way transmission is possible. Half duplex means both way transmission is possible but not at the same time. And full duplex means transmission can be possible on both side, both direction, right? And at the same time, simultaneously, you can transmit and receive the data, right? So that is stated by this physical layer. Then it also state the transmission rate, data transmission rate, right? Like the number of bits per second, right? uh, and the duration of a bit, like how long a bit stay, right? Sometimes, like, you send the data and the data is not received, right, because of some problem in the physical medium. Then how long, how much time that data will stay, right? So that is also defined by physical layer, right? Then the second layer, that is data link layer, right? So this data link layer converts the raw transmission facility provided by physical layer to a reliable and error-free link, right? So here in figure you can see in the both side I have highlighted the data link layer, right? So this layer is responsible, as I told, the error-free transfer of data frame. So here you can see the word frame. So if you see in the figure, right, in the figure, the left side, you can see the arrow is direction downside, and the right side, the arrow direction is in the upside. So the left side, right, it's from for sender side, and the right side is for the receiver side. So at the sender, uh, the data is passing from network layer to the data link layer, right? So network layer is upper layer of data link layer. So you can see the written L3 data, and when you see the square box, right, where I have written this data link layer, where with data they have added T2 and H2. So with data they will add some additional information and they make the data as a frame, right? And you can see like when it will pass the data to physical layer, it is converted in the form of bit, right? And the receiver side you can see from physical layer it is treat as a bits, and that bits when it reaches to data link layer, right, it will define the portion like T2 H2, right? So this H and T, what H and what T we'll see later, right? So it's H is header and T is trailer. So you can see that, and from data link layer, right, that frame will go to the network layer, upper layer at the receiver side, right? So it's define the format of data on network, right? It will make the frames, it will define the format, right, of the frame. It provides a reliable and efficient communication between two or more devices, right? So uh, for reliability and efficient communication, right, this data link layer play a role, uh, and it is mainly responsible for unique identification of each device that uh, that is inside the local network, right? So this data link layer will identify the source and destination, right? So it has facility, it has the functionality like to identify who is the destination and who is the source, right? So generally source we do not need to find. When some device is sending the data, then network should know the destination address, right? So that is important part. So that is the main responsibility of data link layer, right? So if you see the functionality or main function of data link layer, then the first important function is the framing, or to make the frame. So this data link layer translate the data which we can call as a raw data, or we can call as a bits, right? So it will receive the bits from physical layer, right? And it will translate or convert those bits into packet known as a frames, right? And this data link layer add header and trailer to this frame. So actual data is, which is, you can see in the figure I have uh, 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 shown a frame. In that frame you can see header, packet and trailer. So packet is actual data, but this data link layer adds this header and trailer. That is the additional information by the data link layer, right? Uh, and and in this header and trailer, so in header generally this data link layer add the hardware destination and source address, right? That IP address is added by this data link layer of both the source and destination, right? And this trailer, in the trailer they are adding a facility for error control, that is cyclic redundancy check. This is one kind of mechanism, right? So that is added in the trailer, right? So these two part or two additional information is added by data link layer, right? So data link layer receives the data from physical layer in the form of bits, and it will make it as a frame by adding the additional information of header and trailer, right? Header includes the hardware destination and source address, and trailer is for some error check mechanism, right? Then the second task or functionality is physical address. So data link layer header adds the a header, right, to the frame, and that contains the destination address, right? So that physical addressing is done by this data link layer, right? So the frame is transmitted to the destination address mentioned in the header, right? So generally where data is received, or where data will go, where where the address is mentioned in the header, right? Then the next task is flow control. So flow control, as we can say, one of the main functionality of data link layer, right? So flow control means it is a technique, right, through which the constant data rate is maintained on the both side, right, receiver and transmitter. So constant data rate means there is no data is corrupted or no data loss will occur, right? So as I told, like you have two PC or sometimes you have a server and client, then there is not always possible like both have the same hardware configuration, both have the same type of processor, right? So maybe one has the uh, processor which has higher processing power and the other one has the lower processing power. But still, if you want to do the communication between these two devices, right, there should be a flow control, right? Because one who have the higher processing speed, it can transfer the data or it can send the data in higher speed, right? But the device which have the lower processing speed, right, it will receive the data in a slower rate, right? So that flow control is maintained by this data link layer, right? So it ensures that transmitting station, generally server, right, which have the higher processing speed, right, will not exceed from the receiving station, which is generally the clients or our common computer which have lower processing speed, right? Then one function is error control. So as I told, like uh, this error control is achieved by adding some additional bits to the original information or original data, and that are added in the trailer, right? So one such error control mechanism which is known as a CRC, cyclic redundancy check, right? These techniques, most of the uh, architecture are following, right? So this CRC is, right, is placed to the data link layer's trailer, right, which adds to the original message frame before it sent to the physical layer, right? So you are sender side, so sender side means you will go from top to bottom layer, right? So uh, you have to send data from data link layer to the physical layer. So when you send that data, you add this additional information before sending it to the physical layer, right? And if any error will occur, right, then the receiver send the feedback, or we can say acknowledgement for the retransmission of corrected frame, right? So data is transmitted in the form of frame. If some frame are corrupted, some frame is not received properly, then the receiver will send the acknowledgement to the transmitter, like retransmit the data, again send the data, right? So these are the functionality of data link layer, right? Then one more function is the access control. So access control means when you are doing like two or more devices are connected to the same communication channel, right, then the data link layer protocols are used to determine which device has to control over the link at a given time. Like one is a sender and more than one you have receiver, right? uh, or sometimes maybe it happen like you have more than one sender and a single receiver, right? Two PC are sending data simultaneously for a single time to a common PC, right? So at that time, the protocol which are in this data link layer, right, they will use to determine like at what time or at given time, right, which device has to control or to which device the controlling should be given, right? So these are the function, right? So so this is again the function almost we have discussed, right? Flow control, this ensure the distribution of frame, right? Then in the case of broadcast, right, it's controlled the access to almost all the things we have discussed, right? Then the third layer, which is the network layer, right? So network layer is the third layer. You can see in the figure with the uh, pink color, right, highlighted with the pink color. It's control the source to destination delivery of data packet across the multiple nodes, and it controls the operation of subnet. Subnet means the small network. So this network layer is controlling the source to destination delivery of data packet. So let's see. So you can see, like, at sender side, data is coming from transport layer to the network layer, and it will pass that data to the lower layer, that is the data link layer. And at the receiver side, data is coming from data link layer to the network layer, and network layer will pass the data to the upper layer, that is the transport layer. So here you can see, like, network layer, whatever data is coming from transport layer, they will add a packet. It not packet, but we can say additional information, and make the data as a packet, right? So in the both figure you can see, like, H3, that is the additional information provided by the network layer, right? And after adding that information, it will pass on to the upper or lower layer, depends on the your node is sender or receiver. So this network layer manages the device addressing. It will track the location of the device on the network, right? So it have dealing with addressing and tracking, right? It determines the best path to move data from source to the destination, right? Based on the network condition, priority of the service, and other factors. So your network layer will check, like, what is the network condition, uh, to which service it need to give the priority, right, and some other factor, right? Because it is not like today you just use computer for data transmission, right? You do addition to the data transmission, maybe you are doing some other functionality with two PCs, right? So based on that priority, like, am I audible? Hello, am I audible?
Yes, sir.
Okay, okay, fine. Okay, so, right, so depends on the network condition, like, maybe you have multiple path between two devices, right? But one path or one connection have some damage, right? So depends on that network condition. Maybe you have the hybrid net topology, you are using hybrid topology, so you are in the hybrid network, you have the link or the physical connection between two devices, maybe one through ring topology, one through from the mesh topology, right? So based on the network condition, which which service has the more priority, right? So based on that, this network layer will find the best path or best route, like how the data will transfer or transmit from source to destination, right? So that is done by the network layer, right? So that finding the best path means it's kind of routing. So we can say this data link layer is responsible for routing and forwarding the packets, right, in the network. So the router, we can say, is the layer 3 devices, right? And they are specified in this layer and used to provide the routing service within the uh, internetwork, right? And this data link layer, right, it has some protocol. So this protocol used to route the network traffic, right? uh, and those protocols are IP, right? So IP means internet protocol, that we have seen in the TCP IP model, right? So this internet protocol have some versions, like IPv4, IPv6, right? So IP means internet protocol, and V4 means version 4, V6 means version 6. right? So such protocol are used for this routing purpose, right? Which will route the traffic, like in the network, right? If you have using some WAN, then you have thousands of PC in your network. So it is not like at a time only two PCs are doing the communication, right? At a time there are many PCs are doing the communication. Along with that, you are also using some other services, right? So that because of that there is a traffic in your network, so that traffic is routed by the network. If we see the functions of the network layer, then the first function is the internetworking. So an internetworking is the main responsibility of this network layer, right? And this internetworking means it's a logical connection between devices, right? Not physical but logical connection, right? So that is done by network layer, right? Then the second function is addressing. So a network layer adds a source and destination address to the header of the frame, right? And addressing is used to identify the devices on the internet, right? Uh, so as I told, right? So types of address: logical address and physical address, right? Data link layer, right? This also has the functionality of addressing, but here the address is physical address. Physical address means which address? The address which are on the NIC, network interface card, right? So that addressing is done by this data link layer, and the logical addressing, that is IP address, that addressing is done by the network layer, right? So both have the functionality of addressing, but the data link layer is doing the addressing of physical address which is on NIC, and the network layer is doing the addressing of logical address, means IP address, right? So IP address, that's why you can find the uh, device in the internet or in the on the internet, right? So for data transmission or the communication purpose, you need both the address, right? Physical address generally work on locally, in local area network, and the IP addresses work on the internet, right? Then the other function is routing. So the routing is the major component of network layer, right? It determines the best optimal path. Optimal path means you have two paths. If you go from one path, then it will take more time. On the other path, will pass the data with less time, right? So it will find the optimal path, right? Optimal path means best path, right? When you have multiple paths from source to destination, right? So that is done by the network layer. Then packetizing. So network layer receive the packet from the upper layer, right? From upper layer means it is, we are talking about the at the sender side. So then and only we can say like packet is coming from upper layer. So when this layer receive the packet from upper layer means at the sender side, and at that time they will convert it into packets, right? And this process is known as a packetizing, right? And to do this process, right, this protocol IP, internet protocol, right, it is helping, right? With the use of or with the help of this IP, we are doing this process, right? So that's why you can see in the figure here, this header is added, h is added, and because of that it became the packet, right? Right? So here you can see it is in the form of a frame. At data link layer, the data is in the form of frame, and here it is in the form of packet, right? Right? So these are the functionality, right? So again, these are the function which almost we have discussed, right? As I told, a data link layer assigns the physical address locally, and when we need to send data at a remote place or remote location, means through internet. Remote location means far distance, right? At that time we need to use IP address, that is a logical addressing scheme, and it is provided by the network layer, right? Uh, then the congestion control, right? So this layer also providing the mechanism of congestion control. So congestion control is kind of like once you transfer the data and data is not successfully received, then it will send the acknowledgement like data is not received locally, so kindly send or retransmit the data, right? So that is known as a congestion control. So that is also done by this network layer, right? uh, this layer also tackle the issues like transmission delay, transmission time, avoidance of jitters, right? So this is all done by this network layer. Okay, then routing we already discussed, right? So the jitter is also, we can say, it's when there is a time delay in the sending of a data packet or your network connection, right? This jitter is generally generated by this network congestion, right? uh, so it is dealing by, that is deal by the network layer, right? So we are almost 1 hour, so I'll finish the lecture here. This transport layer we'll see in the next lecture, right? By that time, if you have any question, you can ask. Anybody have any question? Okay.